Welcome to a new episode about using FreeCAD to generate G-code for your CNC. In this episode I'm going to do something a little bit different than I usually do. I'm going to also show you how I created the model, because the model has something special. As you can see here, I have an object called drawer parameters. This means that I can modify all the dimensions, all the settings for the drawer. It will update automatically accordingly, and this means that anytime that I need to make a drawer, I can just open this file, modify some values, and everything will be okay. As you can see, the drawer has dovetail joints. It doesn't require any fasteners, any screws, any nails. It's just dovetails. We are going to generate them in FreeCAD, make them adjustable, and mill them on the CNC. Of course, if you want, you can find this file on my Patreon page, but I would definitely recommend you watch the entire video and see how I create this. So let's get started. I will delete this file and start over to show you how I created everything, how I placed the objects, how I intersected them using only the part design workbench. Some things are not ideal, but I wanted to do an exercise to use only the part design workbench to make this design. So let's start the first part of the video. I'm going to delete all the elements here, but I didn't delete this element, which is the drawer parameters, because there's no point in losing time showing you how I enter all these parameters. I'll just show you how to create a new VarSet, because that's what this is called, a VarSet, a set of variables, which is a set of values that we are going to use when creating the object. So I will leave this one just as it is, and I will create a new one, show you how to add the values, and then we will use this one which is already created. So in order to create a new VarSet, you have this button here with a specific icon, and if you hover the mouse you can see create a variable set. Click on it and it is already created, and the pop-up window asks me for the first value. In this example, let's set a drawer width. You have to take care to not use spaces, it won't accept those values. You have to enter the names, preferably with uppercase first letter and all the other letters lowercase. It's a convention, but it's very useful, and you will see in just a couple of seconds why. I will leave the group as base. I can also type another group here. You will see the groups in the other VarSet. For the type, click on this little arrow, and I'm going to select up property length. I can also set a default value for 150 millimeters, and in the tooltip I can write something that will show up when hovering the mouse over the value. So let's say here total width of the drawer. Click OK. You have the option to check the add another. This will pop up another window and you can enter another value. I won't do that because I want to show you how you can add values later when you have finished entering them from here. Maybe you want to add something else. If I have this VarSet here, you can see that FreeCAD automatically changed the name of the label here. It is written with a space, so use the best practice. Use uppercase letters for the first letter of the word and no spaces between words. Now let's change the name. Right click and select rename, or directly press F2. So I will call this variables. You can also modify that from here, from the label. Now if I want to add another value, I have two options. I can either double click on this in the tree view and I have the same pop-up as we had earlier, or I can right click here and select the add property. It looks a little bit different, but mainly they are the same. There is just one thing here different. This is the prefix group name. This means that if I name my variable drawer, let's name it drawer length, and if I check this, the variable name will be base underscore drawer length. Preferably you will use unique names for all the variables. That's the best practice. And if I want to make a new group, let's name it length, I just type the name here. Make sure the type of the variable is correct. You can also write a tooltip. Here it is called documentation, but it is exactly the same. Total length of the drawer. Click on the OK button, and now you have another group with another variable. You cannot enter a default value when using the menu from here, so after adding the variable you have to set a name here. So let's write 600 millimeters. That is the way you create the variables that we are going to use in the sketches, in the layout of the objects, in order to get a nice looking drawer. So now I will delete this new VarSet. Let's use the drawer parameters. I'm in the part design workbench. As I've told you, I'm going to use only the part design workbench. So I've created a new body. I will rename it as front panel, and now let's create a new sketch. I will use the XY plane. So we are going to have a top projection of that board. Let's draw a simple rectangle. I should have set it in the origin, but I can select this corner and the origin, press C for coincident constraint. Now let's set its length, and after selecting the bottom line, pressing the L key to enter a horizontal length constraint, I have this window here. If I click on this little icon, I can go and enter an expression, or simply, as you can see here, press the equal key. And now I have to enter here an expression. The length of this board is going to be the width of my drawer. So how do I access that value that I have entered in the VarSet? It's pretty simple. I've made a reference to the container of the values. Now I want to reference that exact value, which is drawer width. You can see here it's called base_drawer width because I used that checkbox that I told you about for this particular value. After selecting it from the list, press enter again, and now I can close this dialog. I have the length of this board equal to the width of the drawer. The vertical distance for this line, press I, press equal again, and again reference to VarSet, and this is the front thickness, the thickness of the board of the front, which is 15 millimeters. Press OK. Now I can close the sketch. It is fully constrained, as you can see, and let's pad the sketch. Press equal again, type again VarSet and front height. We are going to use the value set there to create a board that is going to be the front of our drawer. I want the front to be below the bottom of the drawer with 25 millimeters. How can I set that offset? Well, I'm going to go to the sketch, to the attachment offset, and to the position for the Z value. I'm going to modify this number, which is 0 for now. Press equal, and I will type -1 multiplied with VarSet front offset. And this means the entire object will be lower with that value. Why didn't I simply modify the position of the object? I could have done that, but I chose not to do that. That is because I want the origin to stay where the origin of the document is. It will make life a lot easier when making clones of objects, moving them around, intersecting them. Modifying the position of the sketch left all this just as they are. If I go to the object and modify its position, you will see that also the origin moves, which is not something that I want because I would have to update everything later on. So now let's hide the origin again. We have the front panel ready. Let's make all the other panels, the rest of the 3 panels, which is left side, right side and back. And after that we'll create the bottom. So create a new body, rename it, of course, left side. Let's create a new sketch. Again, in the XY plane, I will click this button view section. So everything up to the face of the sketch is going to be hidden so I can easily see the sketch. Create a new rectangle this time. Even though I could use the origin, I'm not going to do this because I could have some offset a little bit later. But now let's set the total length of the drawer. Well, since I want the total length of the drawer, I don't care about the length of this segment. I just care about the position of this line. So I will select one of the corners, press I, press equal again, and let's type VarSet dot drawer depth. But I still need to somehow set this value. Well, first let's set its width. Press L for a horizontal distance constraint, press equal, VarSet wall thickness. The wall thickness is for the sides of the drawer, the front thickness is for the front piece. Press enter until everything closes. Now I still have a degree of freedom left to right and the end of the board. For the left to right, I can simply select this corner, press L and use a value of 0. And for the last part, for the position on the vertical axis, I'm going to use a formula. I will select this corner, press I for a vertical distance constraint, press equal, and I'm going to write VarSet front thickness minus VarSet wall thickness. This will allow me, in case I have a difference, to have blind dovetails for the front and normal dovetails for the other corners. If I have the same width, I will also have normal dovetails for the joint between the sides and the front. Now the sketch is fully constrained. I can close this window. Let's pad the sketch too. Press equal, and here write VarSet and select drawer height. Press enter. Now press OK. And I have one of the sides of the drawer prepared. You can see they are overlapping here. It's a good thing because I'm going to create the dovetails on one of the objects and later I'm going to intersect them, so everything will be easier. Now I want to have the exact same thing on the other side, on the right side, so I could use a mirror for that. Turn it active, and now with the body selected, click on this icon which is create a clone. I can rename it left side clone. I have this button here. Let's change the active body, don't forget to do that. Use this button here which is mirrored. I have to also select the plane, which is base YZ plane. You can see the view updated. I have another object here, but this is not going to be a good thing. Let me just hide the initial object, and you can see that the clone actually kept the original object, which is something that I don't like. I just want the part that has been mirrored. For that, I'm going to create another clone from the left side from the initial object, which, let's call it again left side clone 2, and with a left side clone which I will already rename as right side. Now with the right side as active body, go to this button, which is a Boolean operation, click on the add body button, go to the model tree again and select the new clone. Instead of fuse, I will select cut. You can see the view updated, and I have exactly what I want, just a mirrored copy of the initial object. It's a little bit complicated, but I wanted to show you that it can be done using the part design workbench. Now I have this board as left side and this as right side. What I need to modify is its position, so I will go to placement, position. This time I'm going to use this approach because modifying the clones in the tree would be a little bit too much to remember in case I want to modify something. So select the right side, change its X position, press equal again, and let's write varset drawer base drawer width in this case. And it now stays on the right exactly as I want. I still need to make the backboard, create a new body. Let's rename it again backside and create a new sketch. Again, select the XY plane, and I will position the rectangle directly on the final position. I could also draw it from the origin and move it afterwards, but as I've told you, I prefer to do it this way when using just the part design workbench. Click on this button again, view section, select the shorter side, press I, press equal. Let's type varset wall thickness, and for the length of this longer line, press L, press equal, varset drawer width. Whenever you select just one point and press the distance constraint, be it vertical or horizontal, it's going to set the distance from the origin. So if I select just one point, this corner, press L, type 0 here, it will be the horizontal distance from the origin, so it will always stay on the y-axis. What I can still do is move it up or down. Select the same corner, press I for a horizontal distance constraint, press equal, varset drawer depth. So now I have a fully constrained sketch. I just need to select this sketch, make a pad, equal again, varset drawer height. Press the OK button, and now I have the frame of the drawer. Of course, the intersections, the corners for now are just these objects overlapping each other. We're going to solve it a little bit later. We still need to create the bottom panel. So again, create a new body, rename it bottom panel, create a new sketch. Again in the XY plane, press on the view section button, and let's draw a large rectangle this time. Let's set the length, the height, and the position of this rectangle so everything is okay. For the width of the drawer, I'm going to select the bottom line, press L, press equal again, and I will use the drawer width, but I will have to subtract something, which is the total width of the walls minus how much I want the bottom panel to enter inside the walls. So I will subtract, and I will use parentheses. I will write varset wall thickness minus varset bottom depth. As I've told you, this is the value in millimeters that I want the bottom panel to enter inside all these sides. But I'm going to subtract it twice because I have a piece here and one at the end. So I will divide this by 2, and after that I can press OK, press OK again. I will do the same for the height of the drawer. Press I, press equal. So varset drawer depth, varset front thickness minus varset bottom depth, and minus again for the board at the back of the drawer. I will have varset wall thickness this time minus varset bottom depth. Now click on the OK button. We still need to set something. We still need to set its position, but as you can see, I've made a mistake here. It's bigger than it's supposed to be, so let's edit the formula. Double click on the constraint, press equal. The mistake that I made is that I divided by 2. Instead I should have multiplied by 2. So click on the OK button after updating it. Click on OK again. Let's set the top view. Set the position for this corner. Press L to set a horizontal distance constraint. Press equal again, and I'm going to use varset wall thickness minus varset bottom depth. Press enter until everything closes. Select again the same corner. Press I to set a distance from the origin to this point. Press equal. Varset front thickness this time minus varset bottom depth. Press enter, everything is closed, the sketch is fully constrained. I can now close this window and with the sketch selected make a pad. Again, for the length of the pad press equal and type varset bottom thickness. Press enter and everything should be okay right now. Well, almost, because I have also another value here for the bottom, as you can see, which is bottom offset 12 millimeters. So let's do the same approach as we did for the front panel. Let's go to the sketch and modify its attachment offset. Anytime a sketch is attached to something, to a face, to a plane, to whatever it is attached, you are not going to be able to modify these values, the position on the XYZ. Instead of that, you have to modify the attachment offset position and the XYZ here. So if you are frustrated by not being able to modify the position of the sketch, keep in mind that you cannot modify the placement but the attachment offset if that sketch is attached to something. So let's go and modify the Z attachment. Press equal again varset bottom offset. And now, as you can see, the bottom moves the 12 millimeters that are set in my document, and we have already a good looking drawer. Now we need to make the dovetails and the intersections so everything gets cut out. After that, we will have a fully functional, fully parametric, fully customizable drawer. As I've told you a little bit earlier, take into account that you cannot use absurd values, you cannot enter certain variables in a whole range, so use your common sense and just try to get the drawer that you want, not to use values that will make things impossible. But as you remember, we made something a little bit earlier, which is the right side is just a clone of the left side. We use that kind of complicated way of doing things, but it's something good because I can just modify the left side and it will be automatically mirrored. Let's hide the front panel, we don't need to see it anymore. Select the left side, right click and click on the active body to make it active. Now let's select this face and create a new sketch. Again, press on the view section button to hide everything up to the sketch, and let's draw a rough shape of a dovetail, which is something like this. Let's make this vertical too. And now let's start creating constraints to have this fully constrained. I want the corners to be rounded, so select the fillet tool, select the first line, the second one, do the same for this corner, select the two corners and press equal to have an equal constraint. Now select any of the two rounded corners, press K then R to set a radius, press equal, again varset dovetail radius, press enter. I want to do the same here, but here things will be a little bit different. That is because the roundover should be this way, should be to the outside, so when milling matching dovetails I can mill them. If I mill the roundover to the inside, it will be impossible to mill them on the corresponding piece. So how do we do that? First, let's create a new line here, place it random, set it vertical, and now let's delete this line from the first drawing. Let's create some arcs, select the center, select this point and create a random arc. We are going to set constraints a little bit later. And now let's select the endpoint of the arc, the endpoint of the line, and press C for a coincident constraint. Do the same for the other arc. Select the points, press C, and I can already see that I have a little bit of a problem here. Let's move this line and now everything should be okay. In fact, I can select these two arcs and press E to make them equal regarding the radius, but I still need to do something. Select the arc and the lines and press a T constraint. It warns me that instead of the coincident constraint that I already had, it modified it and set a endpoint to endpoint tangent constraint. Now do the same here, press T after selecting both lines. Again, the same warning, everything should be okay. As you can see, I still have a lot of degrees of freedom. Select this point, which is going to be the end of the dovetail, press L and let's set a distance for it, which is going to be varset front thickness minus varset wall thickness. As you remember, the offset of this side wall was exactly that distance, the difference between the wall and the front thickness. Now let's set a radius for these two arcs. As you remember, they are equal, so select either one of them, press KR, press equal again, and let's write here varset dovetails radius again. And now it starts looking as it should, sort of as it should. I also have an angle for the dovetail, so I'm going to select this line and this line, go here and set an angle constraint, and here I'm going to use 90 degrees, so write 90 dg minus varset dovetail angle. And As you can see, I will close the sketch for now. In the drawer parameters for the dovetail angle, I have a variable of type angle, so it is 20 degrees. I have to subtract that from the 90 degrees in order to get the correct angle for the dovetail. Let me just try to zoom in a little bit. I will do the same for this angle. Since I don't have an equal constraint between angles, I will have to set another value here. I could do the same 90 degrees minus angle, but I have another value. I will just click on the OK button, double click on the initial constraint, and I will give it a name, angle. Click on OK, and now if I enter the edit for the second angle, I can simply press equal to write an expression, type dot, which is referring to the object that I'm editing, constraints, which is the list of constraints, and as you remember, we have named one of the constraints angle. I can use that value here, and now both angles are exactly the same, 70 degrees. Select this point, press I for a vertical distance constraint, and then equal varset dovetail offset. As I've told you, I have this value to set the offset from the bottom, and we will also use it to set the value from the top. I also have another value which is dovetail width. For that I'm going to select the highest point and the lowest point again. Press I for a vertical distance constraint, press equal varset dovetail width. How to solve this problem? These lines just going out of order. Select the arc, select the vertical line, and again set a tangent, which is going to change the coincident for these 2 points to an endpoint to endpoint tangency constraint. I still have 1 degree of freedom, which is the total depth of the dovetail. I will select this point and then this point here, press L, and now the horizontal distance will be the distance between these 2 points, the horizontal projection distance. Press equal, let's type varset wall thickness. I want the dovetail to be exactly the thickness of the walls, so for the corners in the back of the drawer I will have through dovetail. Now the sketch is fully constrained. I can now close this sketch, and you can see here the little sketch for the dovetail. Let's make a pocket using that sketch, and for the type, instead of dimension, I'm going to select through all. So now let's take this dovetail and let's modify it to be as many as I've set in this parameters list. In the dovetail section, you can see I have dovetail number. I want 5 dovetails evenly distributed along a distance minus the offset, which at the bottom is 8 millimeters. Let me just modify that to 15. The dovetail updated moved upwards. I want these 5 dovetails to be equally spaced along this space, but I also want them at the end of the board. So how can I do that? What tool should I use in order to make that automatical, to not simply start drawing so many dovetails, and if I change the number, of course this won't be possible. Again, in the left side object, select this tool which is named multitransform. As you can see here, I have a transform body. I can also transform only some features, and I'm going to select transform tool shapes, click on the add feature, and then select the pocket that we have just created. You can see it here in the list. And now let's set the transformations. Right click and let's enter the first transformation, which is going to be a linear pattern. I want many dovetails from here upwards. As you can see, for now they are along the y-axis, and let's change the direction. I'm going to use the base z-axis. I'm going to leave the mode with overall length. The length is going to be set by a formula. Let's press on the expression editor and let's type varset drawer height, and I will subtract the 2 offsets that we have at the top and at the bottom of the dovetail, so it's -2 multiplied by varset dovetail offset. And we still need to modify something, which is the already existing dovetail, so we don't want that calculated. If we don't subtract that value, something will be off. Let me just show you. I first won't modify that. Let's change the occurrences, so press equal and varset dovetail number. Now we are going to have 5 occurrences. As you can see, I have made a little error. The dovetail number variable is a length. I should have set it as an integer number, but for now it works. It converts it automatically. Sometime in the future this might throw an error if it will check the unit, but I don't like how things happen here. As you can see, there is a red space. There's something wrong here, and that is because, as I've told you, we have to subtract also the length of the first dovetail. So go back to the formula and here write minus varset dovetail width. and now you can see they are evenly spaced. The distance at the top is equal to the distance of the bottom. For now I will press OK, then we will modify that multi-transform because we want multiple transformation, of course. That's why I've used this tool. Otherwise, if I just want a linear pattern, I could have used this button, which is simple linear pattern. Well, the multi-transform is a combination of any of these values here, but I want these dovetails also at this end. In order to do that, I will have to make a mirror to the center of this board. How can I do that? Well, for that I will use a datum plane. Let's select the object. I will initially select the back face of this object. If I am able to select it, now I can select it and create a new datum plane, which for now is attached to this face. I will click on the close button, but I don't like that because if something changed, for now the topological naming problem doesn't work as it should with datum planes. It got a lot of issues fixed for other situations, but for datum planes it will throw an error. So instead of using that, I can see here I have origin 001, select the datum plane, go to the attachment support in the data tab, click on the three little dots, click on the clear button to remove the face and scroll. If this is origin 001, I will have the XY plane of 001 or XZ plane or YZ plane. Of course, I'm going to select the XZ plane, and now the datum plane is at the top of the object, but I need to move it at the center of this board. How can I do that? Well, first I need to move it with this little offset, which, as you remember, is the difference between the thickness of the front and the thickness of these three boards. So let's go to attachment offset position. Again, for datum planes, the same that I have used for sketches applies. So if I want to modify the position, I'm going to change the attachment offset, not the placement. So go to Z, press equal, and let's enter the expression, which is VarSet front thickness minus VarSet wall thickness. And now the datum plane should be touching this face. Well, it is not going to be. As you can see, it moved the other way because the datum plane has its top view set like this, so any positive value on the Z is going to move it upwards. If I want to move it to the back, I'm going to have to multiply this with -1 multiplied, and I will use parentheses because I will also modify this formula. Press on OK, and now you can see it is glued to the top of this face. And now how can I calculate the distance of this board? Well, there are a lot of methods. Of course, I have the total length of the drawer. I can subtract what I have already used here. So let's minus and use another set of parentheses. Again, VarSet front thickness minus VarSet wall thickness. And I have to subtract this from the total length of the drawer. So VarSet again drawer depth, and I will have to subtract this. Let's set another row of parentheses. I know this formula might be a little bit complicated for now, and divide this by 2. And now the datum plane should be exactly in the middle of this board. Now let me just explain this formula a little bit. So first I moved it backwards with this small offset here, and I know the total length of this including that small offset, and in order to get half of this line I have to first remove that offset. That's what I did here, and then divide by 2. As I've told you, you can also find the file on my Patreon page. If there's something that you don't understand, you cannot solve it, feel free to ask me on my channel, or if you are in a hurry, or if you want to get the entire file, go to my Patreon page and you can buy it from there. But I think it's a good thing to follow this video, follow along, and try to understand everything that I do here, so you can easily replicate this kind of design for any other object. So let's go to the multi-transform, double click on it and right click here. I have another option, add mirrored transformation. Select the reference and select this datum plane. Click on the OK button, click OK again to close the multi-transform, and you can see that now I have the same dovetails at the bottom of this board, and of course I have them copied mirrored to the right panel. I will hide the datum plane for now. Let's turn on the visibility for the front panel, and now we still need to make all these intersections. Press Ctrl S to make sure everything is saved. Sometimes FreeCAD tends to crash in certain situations, so saving often is a very good practice. So first select the front panel, and I want to intersect it with this side, and with the bottom panel. I want to remove all the parts that are overlapping from these two sides and the bottom panel. Well, first let's set the front panel as active body, and I'm going to make a clone for the left side, one for the right side, and one for the the bottom panel, and in the front panel I will select this, which is Boolean operation, click on the add body button, go to the model, select the first object that I have just cloned, then add body and select the second one, repeat for the third one. And now instead of fuse again, use cut, press on the OK button, and I have the final shape of the front drawer exactly as I want, with the cutout for the dovetails. I need to do the same thing for the back panel. Right click on it and set it active. Now let's create clones of the two sides and the bottom. So left side, right side, bottom panel, but I cannot click on the create clone button with all the objects selected, so I have to take them one by one. It would be a nice thing to create the 3 clones in just one single click. And now make sure the backside is the active body. Click on the Boolean operation, click on add body, and repeat this 3 times for all the 3 objects that we have just created. And change the type from fuse to cut. You can see that I have perfectly cut dovetails. Now I still have to cut the 2 sides, but for cutting the 2 sides I actually only have to cut the left side, because as you know the right side is a mirrored clone to the left side. This way I will also double check that I correctly made the mirror. So select the bottom, make a new clone. As you have seen, any object that I use for a Boolean in the part design workbench simply disappears in the tree here. I cannot set its visibility, I cannot use it anymore, so that's why I create so many clones. But I think this is a good practice to use the clones, because any modification to the object will also reflect in the clone, and it's much easier to follow in the tree with just the 5 objects that I'm using, not a lot of various objects, intersections and so on. So now let's select the left side, right click and set it active. Click on the Boolean button, click on add body, go to the tree and select body 012. Go back to the task and select cut. Now click on the OK button and everything should be cut correct. Let's double check by hiding the front, the bottom and the back side. Let's check that the right panel is perfectly mirrored. It is exactly as I want it to be. It is a mirror of the left panel, correctly placed, everything matches, everything fits together. So now let's try to modify the dimensions of the drawer to make sure all the positioning is correct. And let's go to the drawer parameters and set a different width. Let's set a width of 1000 millimeters. And after recomputing, you can see that the cutouts on the front and on the back are wrongly placed. For the right side, they are in the initial position, the position that I used when first defining the intersections. So let's solve this. Let's go to the front panel. First, let's go to the Boolean, let's go to the clone here. At the placement, I have a value here which is 800 millimeters. So when making the clone, instead of using the formula that I've used to place the object there, FreeCAD copied just the number, the value, the exact value. So press equal and I will use VarSet drawer width, base drawer width. And now the clone that intersects the front is correctly placed, the cutout is correct. I will have to do the same for the back panel, back side. Go to the Boolean, select, probably this should be the right side. Yes, this is the right side, and modify this X instead of 800. Let's use VarSet drawer width. And since these are all the clones that modify their position, now I can safely say that the object is exactly where I want it to be. For the bottom panel, I'm using the offset of the sketch, not the offset of the object, so I don't need to modify that. If I would have used the offset for the object instead of the sketch, I would have had to edit all the booleans and again modify the offset of the clone. Instead of a certain value, use the formula. So if somehow in your design you have something being left behind in the initial position, most probably it is because it has an absolute value, not a formula. Let me just test another situation. When the wall thickness is equal to the front thickness, so the front thickness is 15, let's set a wall thickness of 15 also. Click somewhere away to make the recompute, and it looks pretty nice. We have through dovetails for the front also, so everything should be okay right now. For the next step, we are going to make the G-code to make the jobs and the operations to automatically generate the G-code for all these dovetails to be able to cut them on the CNC. So let's go to the CAM workbench, select the front panel, create a new job. I will use the template 6mm hardwood, and I make sure the front panel is is selected, I will use 3 copies of the front panel. That is because I have 3 positionings. Click on the OK button, and now I have the job created. Let's go to the tools, click on the add button, and I will add the 3.175 millimeters because that's the tool bit that I'm going to use. I will change the horizontal, the vertical, feed speed, the spindle speed, and now I can remove the default 6 millimeters tool bit. I will click on the OK button and I will hide everything else. The front panel is already hidden because when creating a job based on an object, the object will be hidden, and what I can see here on the screen with transparency is the model in the job. Well, in our situation I have 3 models because I have entered 3 copies for it, so I can rotate each of them to both ends and lay it flat for the channel. I will press space twice after selecting the job in order to see the job origin, and now let's start positioning all these 3 items in order to have them correctly placed. The first setup that I will do is going to be this first model, which I will set it up for the channel. Let me first turn off the cooler of the laptop so you can hear me better, and I will also change the mouse pointer, and hopefully now you can see everything that I do a little bit better. So select the first object. I have here the origin and I want it to start from here in that direction. Of course I can go to edit, placement, and rotate it around the x-axis 90 degrees. You can see now that the channel is facing upwards, and that is all that I'm going to do using this menu. For having the origin in this corner for any setup that I have, all I have to do is move it on the y-axis with the total height of the front minus this little piece which is the offset. So select the first body, go to placement, position on the y-axis, click on the value, press equal to enter an expression, and let's write varset front height minus varset front offset. Now in this job I will select this bottom face, create a pocket shape, click on the apply button. Well, it's not going to be okay because I have some wrong settings here. I also have some wrong settings because it's going to start from where this vertical object is. I have a lot of layers. First let's change the pattern to offset. The step over, let's change it to 80%. Go to the depth tab and change the start depth. I'm not going to use the face select and clicking on the arrow. Instead I'm going to enter again an expression, and since the model starts at 0, 0, I can write safely here varset front thickness, and each time that I modify anything it will start at the top of this piece. I have the operation to make the channel. Let's rename it pocket for bottom panel channel. Hide this operation, also hide this object, I don't need it anymore. Let's select the second one and let's place it correctly in order to be able to mill the dovetails at the ends. First will be the left end, and then we will do the same for the right end. So select the object first, go to the edit menu, placement, and let's rotate it around the y-axis 90 degrees. Click on the OK button, and now let's position it. It is pretty easy to see that from the origin it is moved left with the offset. So let's go to the placement, position on the x-axis, press equal, varset front offset. Now let's go to the drawer parameters and make sure the model stays correctly placed. Let's change the front height to 250 millimeters. It's still in the correct position. Let's also change the offset to 20 millimeters. Everything works just as it should. And now let's also change the thickness. Let's give it a thickness of 25 millimeters. And as you can see, I always have the origin in the exact same spot in this corner of the object. And now, as you can see, I have several faces here and I want to make pockets. This means that each time that I modify the number of dovetails, I will have to reselect all the faces and recreate the pocket operation. This is something that I don't want, so I will use a little trick. I will go where I defined the dovetail in the left side, and here instead of the 15 millimeters, which is the thickness of the drawer walls, I will press equal to edit the expression and I will subtract a 0.01 millimeters. I have to write millimeters, otherwise I will have a unit mismatch. Now everything should be exactly as I want, and let me show you what this little trick does to our model. Let's turn again the visibility for the object that I don't want. As you can see, when I'm hovering any of these faces, all of them turn blue, which means they are in fact just a single face, because that 0.01 millimeters is now just a very thin line which connects all these faces together. And now I can select the bottom face, click on the pocket button. Let's set things up here, set an offset with a 50% step over. Let's go to the depth tab, because For now I have a start depth equal to the length of these objects. I always want the start depth to be at 0, so I could select this value and type 0, but I don't want to do that. I want to use an expression which will result in a 0, because this way no matter what I modify I will always have a value of 0. I still have a problem here. As you can see, I have a huge clearance and safe height, and this is not a good thing. I want to also modify that, and I will have to modify that also for the channel. Let's go to the heights tab, and for this operation I want the safe height to be, instead of op stock z max, I will just use the safe height offset, because this object will be placed at 0 from 0 down, so using just the offset, not the height of the stock. Let's go back to the first operation to also change this. Let's go to the heights tab, let's edit this formula, and instead of the stock z max I will use varset front thickness. This is the total height of the stock when milling this piece. Let's copy this value and do the same for the clearance height. Let's rotate the third one, go to the edit menu, placement, and I will rotate it minus 90 degrees, this time around the y-axis. I want to mill the other end. Let's go to the placement, to the position. For the z I will press equal again to write an expression, varset drawer width. I will use the drawer width but with a -1 because I want to move it downwards, and now the object should be exactly at 0, starting from 0 down, which is exactly what I want. Now let's move it on the x-axis, click on the expression, and I will move it to the right with the front height minus again the front offset. And now it will also start from 0, 0, 0 downwards, just as I set everything up. When I'm milling end of boards, when I place objects vertically, I like to start from Z and go down with a minus value. When I mill faces of objects, when they are sitting flat on the table, I like to take the Z0 of the table and place the object above that value. Now let's modify the name of this operation that we have created previously, so it's pocket front dovetails left, and let's create a similar operation with a third object. Let's hide the two operations, and let's create another operation for this piece also. So select this face and create a new pocket operation. Let's change the pattern to offset, the step over to 50%. Let's go to the depth and set a start depth, an expression that will use 0 as start depth. The final depth will be calculated correctly because the object is positioned correctly. We still have to modify the height, so instead of 730 mm safe height, I will use just the offset, the safe height offset without the op z max. The same for the clearance height, and I should have the operation set up. But I see that I missed something also in the previous pocket operation. Let me show you what I'm talking about. Let's hide the other two models. Well, from a top view you can see that the cutter will stop here, so here will be a little corner which isn't going to be milled because I didn't use extensions. Let's first rename this operation pocket front dovetails right, and double click on the operation, go to extensions, check the enable extensions box, and the wire that is created, which is the wire connecting all these pieces. Well, it looks a little bit weird because, as you've seen before, whenever entering to edit an operation, all the models in the job are being turned visible, which is something I don't like, and in a lot of situations it's kind of annoying. Click on the OK button to close the pocket. I still want to do something. Select the pocket operation, scroll down, and you can see here a cycle time of 18 minutes. Let's change the keep tool down to true and the min travel to true, and now suddenly from 18 minutes my operation is 6 minutes and 30 seconds. I will tell you by now that whenever changing the number of dovetails you will have some issues with the extensions. When modifying the number of dovetails you will have to edit these two operations and re-enable the extensions. It's not something that takes a lot of time, but you have to know to do that, to remember to do that. Whenever using this kind of approaches for some projects, I would suggest after each modification, after modifying the drawer, when you want to go to the CNC, turn on the visibility for all the jobs, for all the objects, for the operations, and make sure everything is okay. So let's now rename this job. So it's job front. I have 3 positioning of the objects here, so I cannot do that in just a single file, in just a simple run of the CNC. Let's double click on the job, and if it doesn't somehow throw some errors, which sometimes happen, go to the output tab and change the order by 2 operation and check this button split output. This means that when I export the job, each of the 3 operations will be in its own separate file. I can load them one after the other and run on the CNC after rotating, moving the piece around. So now let's save the file, let's hide the operations, let's hide the stock, let's hide the model and leave the job here because I don't want to remove it, but I want to see everything clear in order to create the next operation, which will be for the sides. As you remember, the right side is just a mirrored clone of the left side, and this means that I can create one single job for both of them if I also turn on the visibility for the back side. And now for a second, let's hide the left side. You can see here that I have some pieces of material that will be very thin, very high, very long, and most probably they will break and the drawer won't look as it should. So let's solve that. Let's turn again the visibility of the left side. I want to move these dovetails just a little bit to the left, not the front ones, just the ones in the back. In order to do that, as you remember, I have created the dovetails at the back with a mirror and I used this datum plane as a reference. So if I want to move them to the left, and I will move them with this radius here, well, it's not a radius, it's a value because I don't have an exact angle here. It depends on the angle of the dovetail. So how can I get that value? How can I calculate that value and reference it to move the datum plane just a little bit to the left? Let's go to the sketch where I define the dovetail. Again, we are going to use that sketch, and let's set a horizontal distance between this point and this point here. Press L for a horizontal distance. Of course, I have redundant constraints, but I will check this button here, which is reference, and I will give this a name, back offset, making sure, just as in the VarSet, making sure I don't have any spaces. Now close this sketch. It will take a pretty long time to recompute everything because I also have the operations in the previous job. So now if I want to move the datum plane with half of the distance, because since it's a mirror it will be doubled, so let's go to the attachment offset of the datum plane, go to position, go to Z, and here, since I'm moving in the negative space, I will subtract the distance and it will be divided by 2 as I told you earlier. So we are going to make a reference to sketch 004. Let's start writing dot constraints. It was back offset, just typing B automatically shows me the value. I can select it from the list and then divide this by 2. As you can see, the dovetails look perfect now in the back. In the front they are still fully rounded because I need this round over here, otherwise milling the inside cut in the front wouldn't be possible and they wouldn't fit. But at the back corner, since it will always be a through dovetail, I can mill them without any round over at this end. I did this right now before milling the left side because this means that the left and the right side won't be identical anymore. I cannot just swap them one with the other. This channel is perfectly symmetrical. The bottom is equally spaced to the left side, so I will make a job to create this channel and I will use it for both sides, for the left and for the right. And then, because the left and the right side can be rotated like this, I will create just one profile operation and I will be able to cut the outside for both of them, taking care when going to the machine to mill one on the inside and one on the outside. Select the left side, create a new job, job sides. First I need to rotate it to be correctly placed on the table, just as I'm going to place it when moving on to the machine. So select the model, go to edit, placement, and rotate it 90 degrees around the Z-axis. And now let's rotate it around the x-axis, but I believe rotating it has also switched the axis, so in order to be easier I will use incremental changes. Now the x is the correct. Let's take a look at on which side is the channel. It is on this side, so I will have to rotate it with a positive 90 degrees. I need to move it to the right with a drawer depth. Let's go to placement, position X, press equal, so it's going to be VarSet drawer depth. And I don't have to subtract that little offset from the front because, as you can see, it is already offset in the other direction, so just moving it with a drawer depth will position it correctly in the origin. Now I need to move it backwards, so go to the Y, press equal or the button for expression, and I will have to move it with a drawer height. This is the height of the board. So now each time, no matter how big, how small, whatever dimensions I set for the drawer, the side will always be in the same position. And now let's create the two operations. I will create first a pocket operation for this face. Let's set the pattern to offset, a step over of 50%. The correct approach is a pocket operation, but how can you select the bottom of these faces and create a pocket operation? Well, you cannot. You simply cannot select all these surfaces in order to get the pocket operation. For this I will have to select all these faces, which will be a problem. It isn't a problem right now because I can simply select them. It takes just a couple of minutes, but whenever modifying the drawer and modifying the number of dovetails, I will have to get back to the pocket operation and modify all these faces. This is something that I really don't like. I want to find a workaround for this. I will make another clone of this object and use that clone as a base for the job. So let's create a clone. I'm using the left side. Go to Parts, Design Workbench, make sure the side is selected, click on the clone button. Of course, it's in a totally different position. So now let's double click on this body to make it active. I will select this face, create a new sketch, use the external geometry to select just this corner, and that's all I need in order to be able to create a rectangle. Make sure I have the X here around the cursor, which is point-on-point constraint. Do the same for this point. As you can see, the sketch is fully constrained. Click on the close button and let's make a pod. I have mistaken something because this object is not starting from the origin, it's the little offset due to the difference in thickness of the front and the sides. Let's go back to the sketch. Let's delete the first point-on-point constraint, which is the one in the bottom here. So I want this to be slightly larger to the right, so all these faces will become one single face. So select the point and the point of the sketch, press H to set a horizontal constraint. Now select both of them and set a length of 0.01 millimeters, and let's do the same for the other corner. I will move it somewhere around. Select the corner of the external geometry and this corner, press H for a horizontal constraint. Now select again the 2 points and press L to set a distance of 0.01 millimeters. Now whenever I hover this face, it is just one single face. This is exactly what I want. Now let's go to the job sides again and go to the general tab, click on the edit button, uncheck the left side, and let's check this one, which is called body 013. I think I should call it a little bit different. Let's press F2 to rename it. Adjusted clone of left side for CNC. I think the name is more than self-explanatory. Now let's go back to the job, press space twice in order to show the origin. Go to edit, go to placement, check the apply incremental changes, rotate it 90 degrees around the Z-axis, click on the apply button, and 90 degrees around the X-axis. Click on apply again, click on OK. Now we still have to move it. Go to the placement position. On the X we are going to use the drawer depth, and as I've explained you earlier, it will position correctly because that offset was already there. Let's also modify the Y. It is going to be VarSet drawer height. This is the height of the sideboards, and now the origin is correctly placed. I don't care about the length of this pod, and that is because it goes from the origin downwards. So now first let's update the pocket sides channel because the base geometry is now missing. Select this face, click on the add button, click on apply, and now the job is correctly set. Well, almost correctly. As you can see, the model's bounding box is now somehow off, and I'm going to double click on the pocket shape, go to the depth tab and change the start depth. Instead of having this value, which is calculated based on the total height of the object, I'm going to use the VarSet wall thickness, which is the thickness of this board without the bottom part. Click on the apply button, and now I have the correct depth, the correct number of passes. Let's also go to the height tab, and here instead of opstock Zmax, I'm going to use again the same VarSet wall thickness plus of course the offset that is set in the job. Do the same for the clearance height, VarSet wall thickness, and now I have everything correctly set up. Let's create the pocket operation, the last pocket operation for these holes. Let's go to the CAM workbench, create a pocket operation, change the pattern from zigzag to offset, a step over of 50%. Let's go to the depth, change the starting depth, VarSet wall thickness. Let's also change these two values. And now I have this operation which mills the pockets just as I want, well, almost just as I want. I want to enable the extensions, which is going to be this line. Let's check it, click on the apply button, go to base geometry and also select this face, click on the add button, go to extensions and check this wire too. Now after clicking the OK button, everything should be correct. Well, almost correct, because let's rename it pocket dovetails. Let's go here and check the cycle time. It's 40 minutes. It's a huge amount of time. Let's optimize this again, keep tool down true, min travel true, and suddenly the time dropped to 12 minutes 52 seconds. So everything is just as I want it to be. I will place this piece, run the sides channel, then run the dovetails, then I will place the second part, run the sides channel, flip the board over, and then run the dovetails, the pocket for the dovetails again. This way I will have the two mirroring parts, the left and the right parts. But before doing that, I still have to go to the job, to the output, change the order by to operation, and check the split output checkbox. Now I have everything set up. I will also create a job for the back panel. If you subscribe to my Patreon page, or if you prefer to buy the file separately, you will also have that job in the file. I'm not going to create it right now. It's exactly the same thing as I did for the sides. So this is how I create drawers. This file is going to help me in a lot of situations when I want to make several drawers of different dimensions. I just go to the VarSet, change the dimensions there, and I can mill all the drawers that I want, all the dimensions. This is how everything went on the CNC. It went pretty smooth. I had some problems with positioning, and this meant that I had to cut two of the pieces later. That's why I have a little gap at the front, but next time I know how to do things properly. I know that my miter so doesn't cut perpendicular, so I will make the cuts also using the CNC. I hope you like this video. Don't forget to subscribe to my YouTube channel, and if you want to support me financially, of course, you can subscribe to my Patreon page, where you will find the final version of this file. You can download it if you are a subscriber, and you also have access to the video without any interruptions. Thank you for watching, and see you next time.